I know that we haven't all quite finished, but I do think it's a good point to have a discussion. All right, so when I look at number 7, and I want to find the value of the fourth term, we all got the same answer. We all said it was 19. But how did we get to that 19?
With the recursive.
With that recursive, right? Why did we use a recursive here?
Because it was closer. Like, it's easier. It was closer to the number.
So notice, when you say it's closer to the number, you're meaning we already had the term right before it, right?
Yeah.
Literally, the definition of recursive is that the now term, the current term, is equal to the previous one plus 3. Did I have the previous one? Yeah. Okay, but McKay, how did you approach number 8 here? Did you use the recursive to just add 3 a whole bunch of times?
No.
No, what'd you do?
Explicit.
You used an explicit here, right? Okay. So, how did you use that explicit?
Plug 50 into X.
Okay, so notice how 50 is the input, and the input can go in for X. And so I think I even saw everyone had a 157. But McKay, the reason I called on you originally is because I really liked something you said in your group. What was the reasoning that you said we should use an explicit here, but a recursive here? Do you remember?
It would just be easier to multiply 2 to 50 than to 3 and 4.
Okay, there was something else you said about this right here. We had a really large what? Gap. I need everyone to pause and pay attention to this because this is the thinking that is the most important side of it. Recursive is really good when you have the previous term, right? It's really easy to just add a 3. But here, how many times would I have to add 3 to get to 50 there? A lot. I mean, it's to go from 2 to 50, how much are you at? How many times are you going? 48, right? 2 plus 48 is 50. Do you want to add 3 48 times separately? Same. This is why we have an explicit equation. Remember, an explicit equation relates inputs to outputs, right? That's what I actually still have up here for my Algebra 1B students as a reminder or review for them, is that an explicit equation relates inputs and outputs where the recursive relates the current value and the previous value. And so we need to pay attention to that idea. It is very simple to just plug in a 50. Then we looked here. I want to keep going with that idea. So notice we have the explicit, we have the recursive given, but for number 9, the 8th term was 78. We want to find the 20th. So which equation would be the easiest or the best to use here? An explicit. Why?
Big gap.
That's a big gap. How many times would we have to add 10 to go from the 8th to the 20th?
12.
Yeah, do you want to add 10, 12 different times? No, me neither. That's why we have explicit equations. Math is actually designed to speed up processes, not make our lives harder. We just have to understand the patterns that are there. So, 200 minus 2, 198. Not too bad, right? Now, if I want to find the 9th term, could I plug that 9 in? Sure, I could plug the 9 into the explicit equation. But if I have the 8th term, what do I have to do?
Add 10.
Just add 10 to it. Which means I'm using a recursive idea. We all clear on that idea? Does that make sense? Starting to get it now? And so like, this is the thing, and I need y'all to understand. One, and I know this is a very backwards way of doing it. You're probably used to a teacher lecturing to you and telling you do this thing and then you practice doing that thing, right? But notice I gave you a little bit of time to explore, to talk and figure things out for yourself. And now when we're having this wrap-up discussion about these ideas, it's clicking more and you're understanding it because you had time to think before I just told you stuff. You need that time to think. You're capable of amazing thinking, and that's what I want to foster. That's what I want to encourage all year long. So then when I look at number 11, I'm going from the fourth term of 80 to the fifth term. So should I do a recursive or explicit? Yeah, I would do a recursive. Notice you could plug in a 5 for that x there. But I've already got the fourth term, so it's easy, just multiply by 2 and get what? 160. Notice that was a very simple step of just multiplying by 2 to get 160, doing it recursively. If I did that explicitly, I would have to do y equals 5 times 2 to the 5th, which means I need to know what 2 to the 5th is. Do you guys know that off the top of your head?
2 to the 5th.
Notice how we don't even necessarily know what that is. That would actually be, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Then do y'all know what 5 times 32 is, just off the top of your head? No, that's okay. Because we shouldn't have used an explicit here. That's actually more work than just recursively saying 80 times 2 is 160. And I will say 5 times 32 is 160. But notice how it's easier to do it recursively? But what about number 12?
Explicit.
I would probably use an explicit. I would probably use a calculator at this point. Because again, it is that idea that it's making a jump. But I will point out, are 4 and 7 pretty close?
Yeah.
Yeah. So I might even still just do this one recursively. Because 5 would be 160, 6 would be 320, 7 would be 640. Right? Like, we can do that. And I want y'all to recognize and understand this very important idea that a recursive, and I like the way that McKay uses language for this earlier, an explicit is great when there's a huge gap, but a recursive is really good if you're just trying to get a little bit ahead, when there's not a huge gap there. Are there any questions about the idea of when a recursive is better than an explicit and vice versa? Does that help settle? Say again? You get it now? Okay. And I do want to point this out, because I didn't mention this earlier, but I want you to understand that the recursive and the explicit are just two sides of the same coin. They're telling the same story. Notice, in this recursive, I'm repeatedly multiplying by 2. How do we mathematically show repeated multiplication?
Exponent.
With an exponent, 2 to the x. Notice, this is the same story, just in two different ways. Right? When I looked here, I was repeatedly adding 10. How do we show repeated addition in mathematics? And I'm multiplying 10 times x. It's the same story, just two different ways. A recursive and explicit equation are not telling you to do two different things. It's just which one's easier in the moment. We all clear on that? Any questions? Comfortable with those ideas? Okay, so I'm going to go ahead and introduce the next lesson. We probably won't get very far, and I'm okay with that. Let me go ahead and pass. It's 1.4. It's called Scott's Workout. There you go. By the way, I do want to point out, I don't know if I showed y'all this before, but if you look at this whiteboard over on my right, your left, that's next to the your phone caddy, notice how there's an Algebraic Connections notebook. Those A, B, and C, and D, those are the 4 things, the tabs that you should have in your notebook. And I've already laid out the first few things that you should have there. This is to help you stay organized. It's also because I will be doing notebook checks throughout the year to give you some practice staying organized. The one thing I wish I had done in high school before getting to college is that I had practiced organization. Because I got really good at it in college, but that was because I but I struggled early on in my college career because I didn't have to stay organized when I was in high school. So I want to give you all some practice staying organized and showing you how it helps to keep things in the correct order. So pay attention to that order up there. because I will have to erase it at some points and then continue it on, but I'll take pictures to record it for myself. So we need to try to stay organized in our notebooks. Okay, so the objectives for this new task, so we're aware, and I'll put it up here each time, is that we want to identify and name the rate of change for a sequence. And that's important, because if you have an additive rate of change, what type of sequence do you have? Arithmetic. But if it's a multiplicative rate of change, you have a geometric. The rates of change define the two different types of sequences. Alright? We also need to practice creating multiple representations of a sequence. What are the multiple representations that you can create? Graphs, tables, pictures, algebraic, and verbal, right? Those are the 5 representations. And the different representations, similar to the different types of equations, they tell the same story, but they reveal different pieces of information. So it's actually good to look at different representations to make sure you understand. But specifically, right, we want to be able to write a recursive and an explicit equation for a sequence. Okay? So this is Scott's workout. Scott has decided to add push-ups to his daily exercise routine. He is keeping track of the number of push-ups he completes each day in the bar graph below, with day 1 showing he completed 3 push-ups. After 4 days, Scott is certain he can continue this pattern of increasing the number of push-ups he completes each day. So day 1, he completed 3. Day 2, he completed day 3. Day 4, 9, right? So notice there's a certain number of push-ups with each day. And so when we come back on Monday, because I will say we only have 3 minutes, so I'm going to show you your homework in a second. When we come back on Monday, you're going to be looking at this idea of how many push-ups will Scott be able to do on day 10. And then based on that, how many push-ups will he be able to do on day N? This should remind you of 1.2 and 1.3. So you want to stay organized in your notebook and look at 1.2 and 1.3 and see, are you dealing with arithmetic? Are you dealing with a geometric? Things like that. So at this point, just so you're aware, I am assigning some homework over the weekend. We barely got started on this task, so I'm going to nix that. I'm changing the homework. Sorry for doing this on the fly. Here's what I want you to do instead of this. So Monday, we're going to keep working on Scott's workout. I'm not going to be wrapping it up. I want you to do the first 3 columns for mathematical representations through common ratio. That's all it is, just defining those, doing the first 3 columns there. So you don't have to do any work, it's just thinking through what we've learned to define those ideas. Alright? Now, I do need your grades from the homework, so I need 1.3 to be turned into the back. And if you, and I realized the other day that I forgot to collect the math literacy, so the ACT science passages, I need those as well. So actually, I'll just collect them by hand. That'll be easiest. So I need your 1.3, the growing dots, and I need the math literacy. This? Thank you, sir. And then 1.3. Thank you, sir. Okay. Do you have the math literacy though? The ACT science passages?
Hey, I ain't worried.
So you need to find it and turn it in.
When is
Remember
it?
the math literacy that we did in the computer lab?
Didn't we do that like?
We can
You already
try
done it,
Yeah.
We were supposed to, but I don't think we ever actually did. So look for it.
When is it?
Huh? It was due a while ago and I actually forgot to collect it. Say again.
Oh, no,
I
no.
think you already
Is it
submitted it
recording?
online.
Is it
when You were doing, remote work. Schoology probably. Did you give me your 1.3? Can't think, can you clear this off real quick? Guys, I need y'all to clean your desk before you leave. So, pass the paper towels around.
No,
I don't think I'm recording it.
Yeah, you are.
Oh, did you want me to pass these around?
Yes, pass the paper towels around. Say again. Oh, the pre-assessment? Yes.
Where's the spray?
Sorry,
Wait,
I'll
no,
do
she's
that.
leaving.
Say again. There it is. The paper towels in the back, I'll get them.
You're welcome.
Here you go, Mona.
I need one for my desk.
There you go.
Oh, this one, do I need it? I was talking about the
No, so that pre-assessment, you turned it in, but I couldn't see any work on there except for these first 4. And it looks like the answer choices didn't show up for you very much. So I was giving it back to you so you could
I'll
retry.
just copy it.
Okay. Yeah,
I don't know where they are.
They're right here.
Oh. Well, that works. Woohoo! I thought she was still in here. I was trying to.
She just left a minute ago, but.
I don't like busy days.
You don't like what?
Busy days.
That's fair.
I think it was still recording the whole time.